Hello to you all. Modeling with blocks is dissection dependent. Simply, one dissection can be clever, the other inferior. There is an old saying, less is more. Well, in synergetic, all these truths are reversed. Where in synergetics, more is less, and there is no science obeying by that rule. In synergetics, a quadriregular tetrahedron equals 6 A modules. And no matter how many A modules one has, nothing but absolutely nothing can be built other than a regular tetrahedron from which this block was derived in the first place. So this is nothing unique, rather just self-evident. In a Z modeling, a quadriregular tetrahedron equals 4 modules. Just like this. And a whole hierarchy can be built if having enough blocks. Isn't this unique and clever? Now, this is clever in this aspect too. By folding these together, we already see the cleverness that we already built in a partial cube just from a quadriregular tetrahedron. Of course, we need more of these to finish the cube, and that block, this block, is existent, of course, in a quadriregular tetrahedron here. So that's very clever. Any polyhedra builder clearly can see the cleverness in one structuring and inferiority of the other structuring. Having more yet do less is the synergetics way. Having less yet do way more is the Zubek's way. As we try to clarify the same fact with the Mite or any synergetics model, we clearly see that in the case of the Mite, the synergetics again using 3 modules per Mite instead of only 2. Now splitting a Mite into 2 is very clever because it forms a half square base pyramid, also known as a half irregular octahedron, which is a very important block. We can build, for example, a hexagonal column. You see, this is a square base pyramid, half octahedron, and this is a bit 1/3 of the hexagonal column, which I already demonstrated in other videos. This hexagonal column, it's a space filler. Never conceived by synergy enthusiasts, yet this is a very important structuring for space filling. Now 3 mites equals a cube volume. Now we have 3 mites in here. We have 3 mites in here, 9 modules all total. But when 3 mites equals 3, one completely becomes inferior because it would need 24 modules like these mites to build a cube. Now 24 is very far from the lowest common denominator, and this particular mite is same in synergetics as in Z system. We need 48 of these to build a rhombic dodecahedron, and we need 24 of these to build this cube, this exact cube. But it's far from the lowest common denominator. There are similar errors throughout the whole concentric hierarchy. One might say, but when mite equals 3, it cannot be modeled into a cube, that it is irrelevant. So people saying in synergy, well, if you have these 3 mites, you cannot build a cube, which is true. But we also cannot build a cube with this claim. Synergetics claim this regular tetrahedron is 1/3 of the cube. True, but it cannot be modeled either. So, if this is valid and accepted, then this has to be valid and accepted also. It cannot build a cube, but it has a cube volume equivalent, which I will show in a second. Now a cube equals 6 can be modeled, and it is the lowest common denominator using the minimum volume identical blocks. Now that is here. We have a cube here, Zubek's cube, not Synergetics cube, and we're gonna see it has all volume identical blocks. And I wanna highlight something. We have Mite in here. As we see, we split it in half, and in this case I show left and right hand cooperation to build a cube, but I also demonstrated this same structure while I using a same oriented mites and still can build the same cube. So for Synergetics to claim that I need left and right is actually not true. It's irrelevant. And besides that, Synergetics also need left and right for their mites to actually cooperate. Not only that, but two mites between one mite and the other mite. There is a difference because these two mites are left and right. Two mites, even the mites themselves are neutral, but by the virtue of this dissection, these indeed come in left and right hand orientations. So Synergetics is poor in modeling and very rich in claims, which they always fail to back up. In a Z system, all claims are backed up by demos, but not only by demos, but also always at the lowest common denominator for every demonstration. One of the greatest achievements of polyhedra modeling ever. Now I want to close this up before I already showed this again, but I want to show these are meaningless. A and B modules, even though Kirby says, which was very interesting, he says, it's not the concentric hierarchy, which is very unique to Buckminster Fuller, but it's the A and B modulo structuring. Well, no, that's absolutely wrong. It's absolutely irrelevant, because I know this has a volume identity of the cube, these three blocks, but it cannot be modeled. But it can be modeled when we have these clever dissections like that. We make three irregular octahedrons, we fold them together, and we have cube. And now we see that this actually contains 9 volume identical blocks inside of this, which would be equivalent to that formula in Synergetics 8, 9. In other words, there is 9 volume equivalent blocks to this cube, but it cannot be modeled. Thank you. See you later.